Today we're going to talk about a specific type of series and how to find out whether it converges or diverges, and actually also find out a range in which the sum can fall. So these specifically only apply to alternating series. Now, 90% of alternating series have the same thing within the series equation. And if you look in the box, it talks about that. Notice that it has a -1 to a power. Now, we talked about this earlier in this unit about the -1 to a power. This is what makes it change sign, alternate sign, okay? Now, what it tells us here is that the alternating series, if the power is just an n, the odd terms will be negative. Odd meaning the first term, the third term, the fifth term, and so on. Not the numbers themselves, just where they sit in the sequence, okay? If the exponent is n plus 1, the even terms will be negative. So actually, I'm going to do this time. This is negative odd terms means it starts negative, then goes positive, negative, and so on. Negative even terms, whoops, that's right. Negative even terms means it starts positive, negative, and so on. That's what it means. And I think that will make it a little more user-friendly. So as you look at your sequences, you can say, oh, it's n plus 1, so it starts with a positive. Or, oh, it's an n, so it starts with a negative. After you decide what it's going to start with, you can basically ignore the -1 term and look at what's left. Okay, and all of the tests are going to be done specifically on everything without the -1 term. Yes, ma'am?
So basically, if it starts with a negative or if it starts with a positive.
Right, that's all it tells us. Okay? Now, here is the test itself. It says alternating series converge if two things have to happen. Number one, the limit of the a sub n term, in other words, what's in the series without the -1, the limit has to be 0. It cannot be 1/2, it cannot be 3, it has to be 0. In other words, it passes the nth term test. Now, about a week ago, we learned the nth term test, and the nth term test usually said it either diverges if it doesn't equal 0, or it maybe converges if it does. Okay, so we're in the maybe converges category when we find that the limit is equal to 0. Now, the second thing that must occur is that a sub n plus 1 has to be less than a sub n for all of the n's. And the simple way to say that is that all the terms decrease, ignoring the signs. So look at the terms in the sequence, pretend like they're all positive. If they're going down every time, it's going to converge. As long as the limit is 0 and they're going down. Those are the two things that must happen. And it's a very easy test to do. That's what makes alternating nice.
So the absolute value of the numbers are different?
Pretty much. Because the a sub n is separate from the -1 to the n, and that's why they say just the a sub n. I thought the same thing. I thought maybe those are supposed to be an absolute value. But no, they're just looking at the terms without the sign changer. Okay? So let's walk through this first one. Determine the convergence or divergence of this sequence right here. So we're going to write the series. So I want you to do your little sigma thing. We're going to start at 1 and go to infinity. All right, so first thing we want to do is put in the sign changer. The -1 to the power, okay? In this specific series, is the first term negative or positive? Negative. It is negative. So go back up to the box. If the first term is negative, the -1's power is just an n. Did you follow what I said? Since this is negative, and this starts with a negative, it means I use an n power as opposed to an n plus 1. Okay? Now, ignoring the signs, what's happening here? What's the pattern? Times, well, what are all the tops of the fractions? 1. What are all the bottoms of the fractions in terms of n? They're just n, aren't they? If I start with 1, they're just n. Okay? So there's the pattern. Now, step 1 of the test says, find the limit as n approaches infinity of 1 over n. That's easy. If I plug an infinity into the bottom, what do I get? I get 0. Okay? So it passes step 1. We move on. Then the next question is term n plus 1 smaller than term n? Are the terms going down in size? 1
Oh, yeah.
to 1/3, 1/2, 1/3, 1/4. Are they getting smaller?
Yeah.
Yes. Yes. So the series, what? Converges or diverges? This one converges. In order to converge, both of those have to be, it has to equal 0, and it has to be a yes on the decreasing. Question?
So we're just looking at the absolute value?
Yes, we're always looking at absolute value. We're ignoring the negative 1. Okay? Yes, sir.
So on the AP test, would it have the same format if it asked us to do this type of problem, or would we have to write it out by ourselves?
You would have to write it out by yourselves, and I'll show you how to do that later on in the lesson. Okay? Yes.
So we always ignore the negative 1?
You always ignore the negative 1 when you're testing for convergence. Yes. If you use the alternating series test, was what we're doing. Okay? Let's try the next one. This time they gave us the formula. Thank you very much for doing that, but that's a pretty ugly formula, huh? Now, they want us to now expand the series. In other words, write out the first few terms. Let's see what's going on. Now, look at the negative 1 part. That tells us just what sign to put first. And it's going to be positive because it's got a power of n plus 1. Agreed? Okay, so when it comes to now expanding the series, you need to know that yes, you could plug in for n every time you do a term. But all that's going to happen is this negative 1 thing is just going to keep alternating back and forth. So when you're plugging in your n's, you can totally ignore that because you now know the pattern. You now know it's going to start with a positive and then alternate. Okay? So now if I plug a 1 into this, what am I going to get? 1 on top and 1 on the bottom. So 1 over 1. Minus. Notice I'm still covering up this negative 1 thing because all I know now is that it's going to be a minus. That's what the negative 1 is going to tell me. 2 over 3. What's the next sign? Plus over 5 minus. Okay, Olo, you have a question.
All right, I was just wondering, like, when you covered the sigma and the negative 1 and everything, when you were plugging in when you were making the series, when you were
Right.
plugging in the numbers. So I was wondering why, how is the answer the same when you're covering that? Because can't the sigma, well, the negative 1 raised to the n plus 1, can't that like affect the answer?
It does. Now, the way it affects the answer is that when you raise a negative 1 to an even power, you're going to get a positive. And when you raise a negative 1 to an odd power, you're going to get a negative. So, since I'm putting n numbers for n in sequence, it means that it's going to be 1 positive, then 1 negative, then 1 positive, then 1 negative. And since I already figured out the first term was positive, and I know it's going to alternate, I don't need to worry about that negative 1 anymore because I already know what it's going to give me, whether it's going to give me a positive or negative. So it's just less work on my part to have to do the math because I already know what the sign's going to be. Does that make sense? Okay, so let's finish this one up. Now, I wasn't meaning to cover the sigma, just the negative 1, actually. So I'm plugging in 4. What am I going to get? 4 over 7 plus ... Now, is each term smaller than the one in front of it? Are they going down? 1, 2/3, 3/5, 4/7? The answer is yes, they are. And the other thing we must test is the limit as n approaches infinity. Now, as of right now, if I plug in infinity, what am I going to get? Infinity over infinity. So how do I fix that problem? The L'Hopital's rule. So limit n approaches infinity. The derivative of the top is 1. Derivative of the bottom is 2. So the answer is 1/2. So, does the series converge or diverge? Okay, look back at the list up here. Can you see this? It converges if the limit is what number? 0. Was the limit 0? No. So the series diverges because the limit did not equal 0. I got a limit, but in the alternating test, it must be 0. It cannot be any other number. Yes?
How come when we do sequence in series and we're using L'Hopital's, we don't have to write L'Hopital?
Because it's not an official... That's a good question. Why are we not having to write L'Hopital's when we do this? Okay, here's why. I have an answer for you. There are some people who can look at this right here and immediately know the limit is 1/2. So you could theoretically not even write this down and know that the limit is 1/2 without doing L'Hopital's rule. Therefore, they would let you get away with it in this instance, okay? All right, good question. I need to be a little more consistent with that. I tend to forget myself. Okay, so are we good with that divergence? Okay, go to the next one. It says each of the following alternating series is going to diverge. I want to know why. Okay, so let's take a look at this one. This one's going to diverge. So I'm not going to write any terms out. Didn't really help me do it last time. Well, actually it did. It helped me figure out whether or not it was going to go down. But if the limit doesn't work, we can throw it out immediately. So let's do the limit first. The limit as n approaches infinity of n plus 2 over n. Remember that when you do the limit, you ignore the -1. You ignore it because that all it is a sign changer. And we're doing the limit of the terms themselves without the signs. Okay? So, can I break this into two separate fractions? Yes. So it would be the limit as n approaches infinity of what? 1 plus 2 over n, and that limit would be 1. So is that enough right there to cause it to diverge?
No.
Yes, because the limit has to be what? 0. So if this was an official problem, okay, you could immediately say, therefore, the series diverges by not the alternating series test, but by the nth term test. Okay? Because the nth term test is when you take the limit as n approaches infinity and see if it equals 0. Okay. And if it doesn't equal 0, it diverges. I mean, if it equals, wait. Okay. The nth term test is what caused it to be 0. I'm going to have to go back and fix this. I got to think about it. Because let's take a look. What does the nth term test say? Now I'm starting to doubt myself. Let's see. Nth term test says up here. If the limit does not equal 0, it diverges by the nth term test. The limit didn't equal 0. Agreed? Therefore, that's why it diverges. Okay. All right. Next problem. All right. Let's see what this one's going to do. Let's take its limit as n approaches infinity of the square root of n over the cube root of n. Oh, that's kind of weird. Now, if they were both square roots, I could put them in the same radical, but they're not. What I can do, however, is write them as fractional powers. What is the power when something's to the square root? 1/2. And something's in a cube root, it is 1/3. So when the bases are the same, we can subtract the exponents, right? So this is the limit as n approaches infinity of n to the what power? Can you do that in your head? What's 1/2 minus 1/3?
It's 1/6.
1/6. Okay. Now, this, even though it's a root, the larger the number you put in, the larger your answer is going to be. Does that make sense? So this limit is approaching infinity, therefore it diverges by the nth term test again. Now, real quickly, let's look at the last one. The last one's just a sequence of numbers, and I don't see much of a pattern there, do you? I see a pattern, but it'd be really hard to write an equation for. And I would need an equation to do the limit. So let's just look at the sequence of the terms. Are they constantly decreasing?
Yeah.
This is 4, this is 2, this is 2. Uh-oh, it's not decreasing, is it?
How does it?
This is 1. That you kind of go, maybe that would be okay. But this one, 1 1/3. I'm definitely going up. So a sub n plus 1 is not less than a sub n, therefore it diverges. Okay, this isn't an official test, so we're not going to worry about writing the sentence down. Okay. Questions on that? All right. Do me a favor, please, and next to the next section, I want you to write the word gold. And the reason I want you to write it is because it is the gold piece of paper on your flip chart page that this is referring to. Okay? Now, we have talked about remainders before, and we talked about them in the terms of Taylor polynomials. But alternating series do something really cool. First of all, the only way you can find the total sum of an infinite series is if it's geometric or telescoping. We've talked about that before. We can't find the sum of an alternating series, but we can find a window that it would fall between, okay? And the way we find that is by finding the error. The error in approximating the value of the series is just the next term in the series. So, here is how this works. It's going to ask you to do a series out a certain number of terms, 5, 6, whatever. And what you are going to find is that the actual sum of all terms, all terms, wrote ATT, is between S sub n minus E and S sub n plus E. Now this makes a lot more sense once we do one. So just write it down for now. That sum of all terms, and I'm going to fix that, because that's going to bug me, is going to be between S sub n minus E and S sub n plus E. ALL. There we go. All right. So S sub n is the sum of the first 5 terms or 6 terms or however many they tell you to go. This one says first 5. The error is going to be the next one in the sequence. Okay? So what we're going to do is we're going to find the range, which is the window where the real sum is going to fall between. And here's how we do this. The first thing we do is write out the first 5 terms. You can do that from this. Now, first of all, tell me, I know it's off my picture, but you can look on yours. Is the first term negative or positive? Look back in the box at the top of your page. It is positive. Do you agree with that statement? Okay. Now, if I ignore this, what's really on top of my fraction? A 1. Okay. So the first fraction is going to be 1 over n factorial, and I'm starting with 1, so 1 factorial. Minus, because it's alternating, 1 over 2 factorial, right? What sign comes next? Plus 1 over 3 factorial minus 1 over 4 factorial plus 1 over 5 factorial. Agreed? So that's 5 terms. So what they want me to do is go ahead and add these up. This is going to be S of 5. So let's clean them up first before we throw them in the calculator. First term is 1 minus, second term is what? 1/2 plus 1 over 6 minus 1 over 24. An easy way to do it is just take this number, multiply it by the next number in the sequence. Because this is 3, 2, 1, and I need now 4, 3, 2, 1. Okay, plus, what's 24 times 5 is 120. Okay, now take your calculator and add all those up. One minus 1/2 plus 1/6 minus 1/24 plus 1 over 120 equals. And are you getting 0.633? Okay. 0.63 repeating. This is S of 5. I know I wrote it on the other end, but I'm writing it close to the number. Okay? So, that's an estimate of what the sum of the whole thing's going to be. I only used the first 5 terms, though. Okay? Now, the error is going to be The error E happens to be the next term in the sequence. So go back to your sequence you were writing. What would be the next one?
Over 6 pounds. I mean,
What sign would it be, first of all?
well,
Minus
7.
1 over
71.
6 factorial, right? Isn't that the next one? Which is negative 1 over 720. Okay? This is my E. Okay? So now I can say that the actual sum S, and I'm going to call the actual sum as S with no subscript, is going to be between that number and E, and then that number and the positive of E. Now, I forgot to say this earlier. Please put that in absolute values. Because if it's negative, it kind of makes the inequality look wrong. Okay? Did you have a question?
I'm confused about the E part.
Okay, the E comes from wherever you chopped your sequence off. E is always the next term. That's the error. Yes, it's the next one in the sequence.
And so 6 times 120 is 720?
Yes, 120 times 6 is 720, yes. Okay, so now I'm going to write it this way. S of 5 minus E is less than the real sum S is less than S of 5 plus E. That's what the words say in math terms. The actual sum S is between S sub 5 minus E and S sub 5 plus E. Okay? And it's always going to look like this. The only thing that's going to change is whatever the little subscript is. And that is determined by the problem, they tell you. Okay? So let's bring the numbers in. 0.63 repeating minus 1 over 720 is less than S is less than 0.63 repeating plus 1 over 720. Now I'm going to stop for a minute. I want you to look at that and see if you understand where everything came from. Are we good?
Yes.
Y'all see where I got everything? Now we're going to use our calculator. Please put this is already in your calculator, right? So I want to do this minus 1 over 720 and copy that down. 6 decimal places is what they're asking for on this worksheet. 631944 is less than S, is less than, and now I think I've shown you this, but I'm going to show you one more time. If you haven't done this before, I want that 6.3 with all its decimals, so I'm going to up arrow, capture it, and then I'm going to add 1 over 720. So you can get all those decimals. So you get 0.634722. Forgot my 0 on the front. Okay. So what did we just figure out? We just figured out that if I had the ability to add up all the terms in this sequence, 1 over infinity factorial, whatever that is, all the way out, my answer would fall between these 2 decimals. That's what it would be. That's what I just figured out. Okay? Now, take your flip chart real quickly, please. We're going to modify what it says just a little bit to make it match our notes. Look for the gold one. Okay? Now, I discovered in first period when I taught this that you guys have never seen this little symbol right here. Many of you have not. You all seen this little E?
Yes.
It's an E, actually. It stands for element. This is a very common mathematical term in college. Okay? But we're going to write this thing. We wrote it a different way. Let's write it this way. S sub n minus E is less than S is less than S sub n plus E. That's the same thing as that. So I'm writing it in more friendly terms because that's what you're used to seeing. That's what we wrote on our paper. S sub n minus E is less than S sub n plus E. And this says the same thing. This says that S is in between, this an plus 1 is the same as E, S sub n minus E and S sub n plus E. It's like a range or like a domain. Okay? Questions? All right, you can put that aside. So turn to the back. We're going to skip the reading part at the top. It's not that it's good, but I'm running short on time, so I want to make sure I get through. Out to the side of this right here where it says, so do we define, I want you to write the word blue, because this is what the blue piece of paper talks about, so that you can connect the two together. It talks about what is called absolute convergence and conditional convergence. Now, before I define these things, I want to look back at this problem we did right here. No, here it is, right here. Do you recognize that 1 over n? What did we call that? Do you remember? What specific series? It's the harmonic series. Now, look in your flip book on the harmonic page. Does the harmonic series converge or diverge?
Diverge.
It diverges. So the plain vanilla harmonic series where they're all positive diverges. But this one that alternates harmonic, what did it do?
Converge.
It converged. So when you're dealing with alternating, sometimes we want to know what the alternating series does in comparison to the all positive series. Okay? And the way we refer to it as the all positive series, and a couple of you have already asked this question, is absolute value. Okay? So what we do when we do these problems is we look at what's called absolute convergence and conditional convergence. Now the harmonic was an example of conditional. The alternating one worked, but the all positive one didn't. You follow what I'm saying? Worked as in converged. So let's define these real quickly. Let me move this out of the way. Okay, conditional convergence. Write this down, please. Conditional convergence. It occurs when the sum of A of n converges, but the sum of the absolute value of A of n diverges. Okay, that's what we just saw. The sum of A of n, now we're assuming the negative one's involved there. The sum of the alternating series does converge, but if you made them all positive, it diverges. And we're going to talk about how to figure out if it does or not. Okay? So, on the other side, absolute convergence is where the sum of A of n and the sum of the absolute value of A of n both converge. So both the alternating and the non-alternating converge when it's absolute. And it kind of makes sense because the absolute value converges absolutely. Right? The absolute value converges absolutely. That's what we have here. Okay? Now, on the homework, if it just says converge or diverge, you test only the alternating one. But if it includes the words conditionally, absolutely, or diverge, you've got to test both the alternating and the all positive and see what's going on. Okay, so let's look at a couple of examples of this. This one, definitely alternating because it's got the negative 1 in there. Agreed? Okay, flip back to the front of your paper and tell me, is this one to start negative or start positive? This one starts negative, okay? Now, this is going to be negative, positive, negative, positive. I might need that. I'm just writing it down notes for reference. Okay? Yes?
Do we still ignore the negative ones to them?
When we do the limit, yes we do. Okay? If we needed to write down a few terms, which we might, I will need this. Okay? Because if you look on the front, if it has just an n up there, it starts negative. Okay? Now, so what we're going to do is we're going to do the limit first. Remember, for convergence, the limit has to be 0. The terms have to go down. Those are the two things that have to happen. So let's check the limit as n approaches infinity. Ignore the negative 1. So we have n squared over n plus 1 squared. Okay, now we're just back to doing limits. We could do L'Hopital. I would FOIL it out first. It's a little bit cleaner if you do. So the top's going to be n squared over n squared plus, you tell me, 2n plus 1, right? Okay, now I need to do L'Hopital's to this. And I'm going to write L'Hopital, L-hop. So the top would be what? 2n, and the bottom would be
2n plus 2.
2n plus 2. Okay, can I take the limit yet? No, got to do it again. So that would be 2 over 2, which is 1. Okay? Yes?
So whenever we do L'Hopital's rule, we have to keep taking the derivative until we can't anymore.
You take the derivative until either the top or the bottom has no ends left. As soon as one of them runs out of ends. Sometimes they run out of ends together. Okay? Now, is this still in the running for convergence?
No.
Look, okay. What does the limit have to be? Go back and look. The limit has to be 0. Is the limit 0? No. Therefore, this one, the series diverges by the nth term test. Now, there is no way that an alternating series could diverge and its absolute value converge. It doesn't happen. It doesn't happen. It's impossible. Because if an alternating series is diverging, that means it's going apart like this, far apart. The up and down is getting farther apart. So even if you made them all positive, it's still going to be going up and up and up and up. Okay? So that one is done. Let's go to the next one. Okay, I really didn't need the sign, so I'm not going to worry about this time. Let's go ahead and go straight into the limit. The limit as n approaches infinity of 8 over the square root of n plus 1. Remember to drop the negative one part. Can I plug in infinity right now? Yes. What do I get? 0. Should I keep going? Yeah, there's still a chance it's going to converge. Okay? Now, this is when I need to really know what's happening with the terms. So, sometimes you can tell just by looking at the sequence if they're going to be getting smaller. Sometimes you're going to need to write it out. But in actuality, it doesn't matter what the signs are, does it? Okay? So we have 8 over, if I plug in 0, it's going to be 8 over the square root of 1, and then 8 over the square root of 2, 8 over the square root of 3, dot, dot, dot. Are those getting smaller?
Yes.
Yes. Denominators get bigger, equals fractions get smaller. Okay? So a sub n plus 1 is less than a sub n. You have to write that down. You have to show the limit is 0. You have to write down that you tested and made sure that the terms are getting smaller. Therefore, a sub n converges. I know that the alternating one converges. For sure. I don't know what's happening to the other one. But this one right here, the limit equals 0 for nth term test just says it might converge. So this doesn't really help me to test and see if this thing really does converge. But what does help me is the test that we learned yesterday. This is almost a p-term series, a p-series, because the exponent's a 1/2. But I got that extra 1 thrown in there. So we're going to do a comparison test to see if it converges or diverges, okay? Now, we're going to compare to 8 over p to the 1/2, okay? We're going to just take that plus 1 out because that's messing everything up. And the 8, it doesn't really matter. Okay, on a p-series, if the exponent's a 1/2, go look at your flip chart, go to the p-series page if you don't know. Go to your flip chart. What does it say? Okay, so p-series says it converges if p is greater than 1, diverges if p is less than or equal to 1. So which one does this fall into? This is a diverges. And this diverges, okay? So we're going to do the limit comparison because that was the nice and easy one last time. So the limit as n approaches infinity, remember to put the simpler one on top, or n, this should be n to the 1/2, I apologize. So we're going to have 8 over the square root of n, go ahead and change it back to that, and then 8 over the square root of n plus 1. Compare the two. Remember doing this yesterday? Those of you who were here? Okay. So this will be the limit as n approaches infinity of 8 square root n plus 1 over 8 square root n. I just flipped the bottom one up. Okay, what's going to happen to the 8s? They go away. That's why I use the 8 on my comparison. So this now becomes the square root of n plus 1 over n in one square root sign. We did that yesterday too. So this is the limit as n approaches infinity of the square root of 1 plus 1 over n. Am I going to get a number answer? Yes. Okay, for this test, I don't care what the number is. I care that I get a number. And if I get a number, the two series do the same thing. So therefore, this one's going to do what? It diverges. Therefore, the absolute value of A of n diverges. Okay? So the absolute value one diverges, the regular one converges. So is that the conditionally or is that the absolutely? That's the conditionally. Converges conditionally by the alternating series test. Now notice I abbreviated alternating. I think you can too.